Hello my dear friends, how are you today? By the way, I would like to introduce myself. My name is Jerome Aveles Algodon as your math helper. This moment, I would like to help you for some reason. A reason to help you and to answer all your questions in mathematics. Okay, as what mathematicians said, a mathematics is a subject that we do not know what we are talking about. So, this is what we called a mathematics is very critical, but it is easy if you understand and you will use your brain exactly. Okay. Jan von Neumann, he was born on December 28, 1903. He is a Hungarian mathematician, an American mathematician, a computer scientist, and a physicist, and a polymath. And Jan von Neumann was generally regarded as the most and foremost mathematician of his time, and said to be the great and the last representative of the great mathematician, a genius who was the comfortable integrating the pure mathematics and applied sciences. Okay, this moment, this time, I would like to introduce some topics of mathematics. Okay, I am so excited. Are you excited too? Okay, let's be ready. Okay, my dear friends, I'm back. Okay, this moment, we're going to discuss about the Euclidean algorithm, the greatest common divisor, and also the prime factorization. So, are you excited, my dear friends? Okay, let's talk about this. But before anything else, once again, good morning, everyone, especially for you friends. Okay. Before anything else, I would like to have a motivation for you, my dear friends. Okay, let's recap about our learnings about the English alphabet. We all know that English alphabet has 26 letters, and each number, each letters is important in the symbol and also in the variable of mathematics, as we use them as a variable to represent the symbols. Okay. The English alphabet is very useful for our motivation for this morning, my dear friends. Okay. We are going to let A is in number 1, B as in number 2, C as in number 3, and so on and so forth up to Z. A total of 26 letters. Okay. So that we can use this as a code for our terminologies for this topic about this discussion. Okay. The code. Okay, code number 1. 7, 8, 5, 1, 20, 5, 19, 20, 3, 15, 13, 13, 15, 14, 4, 9, 22, 9, 19, 15, and 18. So, what is the terminologies in mathematics that we have if we are going to use the English alphabet? So, the answer is... What is your answer, my dear friends? The answer is the greatest common divisor. Okay, you have a correct answer. Okay, number 2. 5, 21, 3, 12, 9, 4, 5, 11, and 14. 1, 12, 7, 15, 18, 9, 28, and 13. So, what is the terminologies in mathematics? What is your answer, my dear friends? Okay, the answer is Euclidean algorithm. Okay, terminologies number 3. 16, 18, 9, 13, 5, 6, 1, 3, 20, 15, 18, 9, 26, 1, 29, 15, and 14. So, what are the answer? Okay, what is your answer, my dear friends? Okay, the answer is prime factorization. Okay, this 3 is very important in our discussion for this morning, my dear friends. The greatest common divisor, the Euclidean algorithm, and also the prime factorization. Okay, but before anything else, let's talk about what is the definition and the introduction of Euclidean algorithm, my dear friends. Okay, definition. In mathematics, the Euclidean algorithm or Euclid's algorithm is an efficient method for computing the greatest common divisor, okay, which is GCD of two numbers and the largest number that divides both of them without leaving a remainder. Okay, next. It is named after the ancient Greek mathematician Euclid, who first described it in his Element. It is an example of an algorithm, a step-by-step procedure for performing a calculation according to well-defined rules, and is one of the oldest algorithms in common use. Okay. The father of geometry. The father of geometry is also Euclid. Okay, Euclid is a very genius mathematician. This picture is Euclid. Next, definition. Recall that Euclid's algorithm allows one to easily compute the greatest common divisor, or what we call GCD, of two numbers. It is based on the following observation. If A is equal to QB plus R, where O or where 0 is less than or equal to R and less than B, then GCD is the quantity of A and B is equal to GCD B and R. The B and R is the remainder. Example 1. Find GCD of 54 and 888. Okay, my dear friends, let's find the GCD. Find the GCD of 54 and 888. So, we all know that 54, we're going to use the long division for this process so that we can find easily the greatest common divisor. Okay, as we all know that 54 divides 88 is equal to 1. And 1 times 54 is equal to 54. And also, 888 minus 54 is equal to okay, let's continue, my dear friends. Okay, 54, 1 times 54 is 54, and 88 minus 54 is equal to 34, and bring down 8. So, we're going to use 6 because 6 is can multiply 54 to 324. So, 6 times 54 is 324. And 348 minus 324 is equal to 24. So, our remainder is 24 and our quotient is 16. So, therefore, we're going to use a Euclidean algorithm so that we can find the greatest common of our problem. For example, 888 or 888 is equal to 54. 54 came from here and followed by here. And then 16. 16 is our quotient. And the remainder is 24 plus or positive 24. So, in this moment, 24 is our remainder. So, 54, we're going to transpose the 54, or we're going to put this in another side, and also the 24 will transpose. Okay, 24 and 2. We're going to use 2 because 24 times 2 is 48. And positive 6. Okay, for example, and 24 divide 54 is equal to 2. You will use 2, and then 2 times 24 is 48. And 54 minus 48 is equal to 6. So therefore, here is 6. So we come up 6 from dividing 54 to 24. Okay, 6. Okay, we're going to use again, and we're going to transpose again the 24 so that we can come up the 0. Okay, 24. Okay, we're going to use again the remainder. Bring down the remainder, and also we're going to, the factor of 24 is 6 and 4 because 6 times 4 is 24, and the remainder is 0. So therefore, the GCD of 54 and 888 is equal to 6. Okay, the 6. Therefore, my dear friends, the GCD of 54 and 888 is equal to 6. So, this is our final answer. Okay. Okay, another, my dear friends. Find the GCD of 7 and 876,543 or 876,543. So it is quite bigger number. Okay, but we're going to solve this one. It is very easy, my dear friends. Okay, my dear friends, find GCD of 7 and 876,543. Okay. We're going to use the long division so that we can find the quotient and the remainder of each number. Okay, 7 and 8, 7, 6, 5, 4, and 3. Okay, it is quite bigger number so that we can also use calculator, but calculator can't define this. Okay, 2, 2, 2, and 0. Okay, and so on. Over 3. Okay, it is quite bigger number so that we're going to use another method. Okay, 876,543 is equal to 7, and also the, oh no, okay, 7 and 125, 220, and positive 3. Okay, this one, 7 is equal to 3 because the factor of 7 is, we all know that 7 is a prime number. So 3 and 3 and 2, 3 times 2 is 6, and positive 1 is a total of 7. So therefore our GCD of 7 and 8, 7, 6, 5, 4, 3 is equal to 1. And 1 is also and 1 is not a prime number, but it is a relatively prime. Okay, let's proceed another. A prime. Okay, my dear friends. Okay, what is prime, my dear friends? A prime is defined as any counting number that is divisible by exactly two distinct counting numbers, 1 and itself. A number that can only be exactly divided by itself and by 1. And also, a number is called prime when its only factors are 1 and itself. The first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 39. So, let's proceed. A table of prime numbers starting 2 and 997 or starting 1 to 1000. This is also a table. So, the first 10 prime numbers is 2, 3, 5, 7, 11, 13, 17, 19, and 23, and 29. Okay. I have a question for you, my friend. Why is it 1 not prime? And why is 2 prime? Even though it's even. And why is the 2 the only even prime numbers? Okay. Why? A prime is defined as any counting number that is divisible by exactly two distinct counting numbers, 1 and itself. Therefore, 1 is not prime because it is divisible by only one distinct counting number, which is 1. And 2 is prime because it is divisible by two distinct counting numbers, 1 and 2. Okay. Another example, my dear friends. Prime factorization. Okay. Prime factorization is very useful in determining the factor of each number, whether it is prime or composite or neither. Okay, for example, we're going to use the factor 3 so that we can define the factors of each number. Using the factor 3 is one of the method that you can identify whether it is prime, composite prime, or neither. Okay. Okay, my dear friends. This is factor 3. So, factor 3. Factor 3. Example. Letter A. The factor of 30. Okay. What is the factor of 30? What is the 1 prime and what is the prime factorization of 30? Okay. We're going to use 10 and 3 because 10 times 3 is equal to 30. And the factor of 10 is 2 and 5, and we're not going to factor 3 because 3 is a prime number. Okay, therefore the correct answer or the prime factors of 30 is 2 times 5 and times 3, and a total of 30. Okay, my dear friends, are you okay over there? Just keep watching. Okay, for example, letter B, 63. Okay, the factors of 63 is 9 and 7. And well know that 7 is a prime number and 9 is factorable by 3 and 3. Therefore, prime, you come up a product of 9 and you come up the factors of 9 is 3, which is 3 is a prime number. So we're not going to factor again the 3 and 3 because it is already a prime number. Therefore, the factors of 63 is 3 times 3 times 3 times 7 is equal to 63, or 3 squared times 7, and a total of 63 also. Okay. Letter C. 27. Okay, 27. The factor of 27 is 9 and 3. So, again, 3 is a prime number and the factor of 9 is 3 and 3. and therefore you come up again the 3, which is also a prime number, and therefore the prime factors of 27 is 3 times 3 times 3, in a total of 27, or 3 raised to cube is equal to 27. Okay, again, letter D, my friends. Keep watching, my friends. 56. Okay, 56. What is the factor of 56? 8 and 7. And 7 is a prime numbers, and 8 is also a composite prime numbers. So, the factor of 8 is 4 and 2. And we'll know that 2 is a prime number, and 4 is a composite prime number, which is factorable. Okay, the factor of 4 is 2 and 2. So therefore, you come up the 2, which is prime number. Therefore, the factors of 56 is 2 times 2 times 2 times 7, or 2 raised to 3 times 7 is a total of 56, which is 2 times 2 times 2 times 7 is a factor of 56. Okay, letter E, the last letter. 100. Okay, we all know that 100 is a perfect square, and the factor of 100 is 5 and 20. Okay, 5 is a prime number, and the factor of 20 is 4 and 5. And 5 is a prime number. The factor of 4 is 2 and 2. Therefore, the prime factor of 100 is equivalent to 2 times 2 times 5 times 5, or what we call 2 raised to 2 times 5 raised to 2 is a total of 100, because 2 raised to 2 is equal to 4, and 5 raised to 2 is equal to 25, and 4 times 25 is a total of 100. So, get it? Okay. Okay, from now on, my dear friends, God bless you, and thank you for watching. By the way, my dear friends, I am your math helper. If you're going to have any problem, just call me and just message me so that I can help you as long as I can. And I thank you.